The for statement. The for statement has the following syntax. We have the initialization, we have the condition, and we have the incrementation. We use the reserved word for, and then we have the statement that we're going to execute. The for loop was actually set up to make it easier to create loops that are going to execute a specific number of times. So the initialization is where we're going to put the variable that's going to control the loop. The condition is where we're going to put the condition, like the count is less than 5. And the incrementation is where we're going to increment the control variable. So here's a flow chart for a for loop. You have the initialization, you have the condition, and if the condition is true, then we're going to evaluate the statement, and then we're going to do the incrementation. So the incrementation is going to be the last thing that's going to happen in the for loop. And here they're comparing the for loop to the while loop. So if we're going to use a while loop just like we have a for loop, then the initialization statement will go outside of the while loop. Here's where your condition is going to be. You're going to have a statement, then you're going to increment your control variable. When I say control variable, I'm talking about a variable that's going to be inside of this condition that's going to control your loop. An example of the for loop. So here's the for loop. They're declaring a variable count and setting it equal to 1. They're saying while count is less than or equal to 5, count plus plus, and they're going to print out the statement. The statement is going to get printed out 5 times. The initialization section can be used to declare a variable. Like the while loop, the condition of the for loop is tested prior to executing the body. Therefore, the body of the for loop will execute 0 or more times. The incrementation section can perform any calculation, so you don't have to do num plus plus or num minus minus. You can do num is equal to itself minus 5. The for loop is well suited for executing statements a specific number of times that can be calculated or determined in advance. See multiples.java and stars.java. So in this program, they create a constant, then they declare some integers, value, limit, mult, and count. They have a scanner object. They prompt the user to enter a positive value. They store what the user enters into the variable value. Then they ask the user to enter an upper limit. They store that into a variable named limit. Then they print out a statement, the multiples of, and then whatever value they entered between the value and the limit that they set. They use those values inside of the for loop. Then they're incrementing this for loop by saying multiple is equal to itself plus the value. So like if they entered in like 5, they're actually incrementing by 5s. Then they're incrementing this count variable. This count variable will set to 0 outside of this for loop. So every time they come into this for loop, they're incrementing it by 1, and then they're dividing it by 5. So per line was actually set to 5. So they're finding the remainder of that. And if it's equal to 0, that means they got up to 5. Then they're printing out a new line character because they're printing out the multiple here, but they're actually creating the line right here. So this is what the output looks like. So the loop is actually running this many times, but it's running across, and that count variable was used to create a new line. So once it prints out 5, it's going to move out to the front and then keep going until it gets to a multiple of 5. But here's their output. Then they have this program called stars.java. So this program has a constant for the number of rows. Then they set row equal to 1. And while row is less than or equal to the max rows, they do row plus plus. And then inside of this for loop, they have a nested for loop, and they're going to print out a star. So this is what this looks like. It's just going to be a triangle. For every iteration inside of that inner for loop, you're executing more and more times. Quick check. Write a code fragment that rolls a die 100 times and counts the number of times the 3 comes up. So here we're going to use the die object, and we're going to roll it inside of a loop. We're going to use a for loop, and we're going to use a control variable of, say, count. Then we're going to increment count by 1 until count gets up to 100 times. With inside the for loop, we're going to roll that dice, and if the face value is equal to 3, then we're going to increment an additional counter that's going to count the number of times that we see a 3. And here's what they have. They instantiate their die object. They set count to 0. They come inside their for loop. This for loop is going to run 100 times. Then they're saying if the roll is equal to 3, they're going to increment count. And then once they're done with this loop, they're going to print out the count. Each expression in the header of the for loop is optional. If initialization is left out, no initialization is performed. If the condition is left out, it is always considered to be true and therefore creates an infinite loop. If the increment is left out, no incrementation operation is performed. So I created this program to demonstrate the for loop. I went ahead and just set up a real simple for loop. Remember, inside the for loop, inside these parentheses, we have 3 different types of statements. We have the initialization, we have the condition, and then we have the incrementation. So here is my initialization. So I'm creating a variable. Then I'm saying while x is less than 100, execute this statement. And then when I'm done executing the statement, I'm going to increment x by 1. So I'm going to go ahead and compile and run this program. And here's my output. X started at 0 and ended at 99. So the condition said, keep x less than 100. So one of the things the lecture slide talked about is that you don't necessarily have to increment by 1. You can do whatever you want in this one. So I'm going to go ahead and increment by 5. So I'm going to say x is equal to itself plus 5. I'm going to go ahead and compile and run this program. And here's my result. X started at 0, then it went to 5, 10, 15, 20, and it went all the way to 95. So one of the things that I can do with the for loop is I can create a table. So I can do this by having nested for loops. So this outer loop is going to be my row and this inner loop is going to be my columns. So if I output any data inside of my inner loop, and if I don't use a print line, then it's going to keep adding items horizontally. So I'm going to go ahead and add a statement. So I went ahead and added a statement inside of my inner for loop. So as the outer loop is executing 10 times, the inner for loop is going to execute 10 times. So inside of this inner for loop, I'm basically just taking my row times my column. And then when I'm done executing all my columns, I'm going to come to this line right here and I'm going to make a new line. So for every row, I'm basically adding a new line. So I'm going to go ahead and compile and run this program and we can see what the output looks like. And here's my output. Now this doesn't look as nice as I thought it was going to look. And that's because inside of this output console in Notepad++, it's not giving the same width of a space as it does these numbers. So I'm going to go ahead and compile and run this program in command prompt. And here's my output. You can see it didn't make enough space because I have this 100 that's 3 digits long. But for the most part, this table looks pretty nice. So another thing that we can do with nested for loops is we can make different shapes. So I have an outer loop controlled by A, and it's going to execute 10 times. And then I have an inner loop that's going to execute 10 times. So let's see what the shape looks like. And here's what my shape looks like. So for every outer loop, I'm executing the inner loop the same amount of times. Now what I can do if I wanted to make this shape a triangle, I can put an offset in my inner loop. So when I say put an offset in my inner loop, that just means instead of setting B equal to 1, or instead of going to 10, I can modify this depending on what the value of A is. So let's see what happens if I set B equal to A. So here's the result of setting B equal to A. So in my inner loop, instead of setting B equal to 1, I set equal to A. So every time A increases, B is going to start at a higher number. So we have a shape where the inner loop is actually executing more times at the beginning and less times at the end. So now what I want to test, instead of having B equal to A, I want to make this condition where B is less than or equal to A. So at the very beginning, A is going to be 1. So that just means the first time we execute our inner loop, we're only going to do it one time. And as A increases, we're going to execute the inner loop more and more times. So let's see what this looks like. And here's my output. You can see I just mirrored what I did above just by moving where I have my A inside of my inner loop. Okay, so I modified this program just a little bit. So what I did is I made another loop. So this other loop is basically just taking what we just did before, but I'm setting C equal to A. And I'm saying while C is less than or equal to 10, but this time I'm putting a space. So what I'm going to do is I'm going to put a certain number of spaces before I put my stars. So let's see what this looks like. And here's my output. So at the very beginning, C is equal to A. A was 10. So I have a bunch of spaces before my star. And then in my star loop, B is equal to 1. But the condition is while B is less than or equal to A starts off at 1. So this is only execute one time. So while my space loop is executing less, my star loop is executing more. And I was able to make this shape. So let's play with this shape some more. So I like keeping my spaces here, but what I want to do is I want to make this a real triangle to where it looks more like a pyramid. So I want to keep a 1 here, but on this one I'm going to go to a 3, and I want to keep getting it bigger. So what I want to do is I want to modify how often I run this star loop. So that means I'm going to mess with my condition. So here's a condition that I want to modify. So initially this is only going to run one time, and I'm okay with this running one time. But when I get to the second loop, I want to print out 3 stars. So when A is 2, I want to print out 3. So essentially what I want to do is I want to take A and I want to multiply it by 2 and I want to subtract 1. And this is going to give me the number of stars that I want. And here's my output. I basically just made the top of a diamond. Now if I wanted to make the bottom part of this diamond, all I really have to do is come over here and just reverse my logic. So this is a for loop. It makes it pretty easy to execute statements a specific number of times.